Hoppity hoppity hop, hoppity hop, 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 hoppity hop. Ow!
Ajay, I have a new question for you.
Hmm.
If you had to rate the weather last few years in Pune, how would you rate it?
Average?
Why average?
Because there are no winters.
Is it only your opinion or opinion of everybody?
It is the opinion of everybody, especially people who have been staying here since decades, that summers are hotter and winters are also hotter. So since winters are hotter, there are no winters, and summers are hotter, so it's now everybody is buying ACs and coolers.
What about children's?
They have never seen a cold Pune. Pinky was teaching kids, so there are 4 seasons: summer, monsoon, winter, spring. The kids said, "Ma'am, what is winter? There is no winter. There is only summer and monsoon." Then she said, "Yeah, I know there is no winter, but since there is winter in the books, remember summer, monsoon, winter, spring."
Finding a place to call home is incredibly hard. How do you do it when everything around you seems uncertain, unpredictable? There's price, work, proximity to family to think about, but also threats brought by climate change. Because all those patterns of weather we once knew instinctively now seem different. Winters are no longer cool, and those sweaters gather dust. Summers are so hot that you want ACs in every room. Heat waves strike even before summers have officially kicked in. Rains bring too many floods for far too long, flooding basements and rooms. Untimely cyclones and rising seas eat through newly laid coastal roads. Or droughts hit where there was never a problem with rain.
There is no water left in the Bid area. It used to rain by the 7th of June, but there are still no signs of rains.
How do you then find a place that is safe from all of this? What neighborhood or city should you live in? One that doesn't flood or have water shortage or feel excessively hot. So let's imagine this. In a hypothetical future, you would like some help with choosing a climate-safe location for your next home. A property, a neighborhood, or a city that is safe from the erratic behaviors of the climate. Imagine there's something like this to help you out.
Hello, Mr. Santosh. Boss, that 2 BHK you showed me last week, no, I read news that it got flooded in October. Basement bhi flood hota hai kya? Hey, find out, no, I have electric car, man. I don't want to take risk. Hello, is this Yes Broker? Hey, so I'm looking for a flat and I have 2 conditions. First one is that area should not be hot. It should have trees and greenery and all that. Second one, I don't want water shortage, okay? No tanker buying and all that. Sea facing. No, boss, I don't want sea facing. Are you seeing what's happening in Bombay? My friend bought a house for 20 crores. Now it is full of salt water. Bloody salt factory can start now. They're saying in 2 years the whole...
Worried about your future investment? Want a house in an area that'll be safe from flood, heat, cyclone and sea level rise? Log on to bharatclimate.com and find a property that'll remain safe from climate change. bharatclimate.com. Apna paisa mat dubao.
Welcome to Imagined Tomorrow. This is the show where we imagine hypothetical futures for India. Futures that could become a reality when science and tech try to solve problems within our uniquely Indian contexts. What would these scenarios look like? And should we even make them happen? That's what we'll talk about. I'm your host, Shreya. This is going to be a 3-part mini-series. In part 1, we take on a future where we can all pick and choose locations for our homes that will be safe from climate change. In part 2, we explore a future where you may not be able to make these choices. But that's okay, because we'll see how your current and future homes can be made more climate safe. And in part 3, we'll bring you something from the archives of history, a story that serves as a warning for our future. So, part 1, a future where you can pick a climate-safe property, neighborhood, or city. What would it take to do this using science? And what should we be wary about? Welcome back. Do you remember bharatclimate.com from our fictional ad?
Log on to bharatclimate.com.
Platforms like these actually exist, for the US at least. I came across a couple of them earlier last year, and very soon after I did, I called a friend.
Oh no, please don't ask me to turn on my video.
Just to say hi, then you can turn it off.
I washed my hair. Hi.
This is Sandhya Ramesh, science editor at The Print. Since this is an audio-only podcast, you can't see her. But if you want to see her, you should check out her incredible science videos that she puts up on The Print's YouTube channel. Anyway, let's get back to the call that I had with her.
So I have climatecheck.com open.
If you open this website, climatecheck.com, there's a search bar at the top. There you can enter either a PIN code, the address of a property, name of a neighborhood, or a city in the US. And when you press enter, it gives you a report on how climate change will affect that specific location over the next 30 years. Since Sandhya has lived in both India and the US, I asked her to put in any PIN code of a place that she's familiar with.
11417.
So this is Queens, New York.
Yeah.
And once she hits enter, this is what she sees.
Extreme risk of storms. That sounds about right.
For each location, Climate Check throws up a risk score for 5 extreme weather events: storms, fire, droughts, heat, and flood. The risk score goes from 1 to 100, where 100 means that things are going to get really, really bad in the future. And the location that Sandhya picked in Queens, New York, that has an extreme storm risk of 100. Now, the state of New York is not a stranger to storms, hurricanes, or heavy downpour. But climate change is predicted to make these extreme rains more pronounced as the years go by. So, more storms each year with a lot more rain per storm. So, one more thing you can do is go to Redfin.
Okay, 1 second. Redfin.
Redfin is a property listing website in the US, just like Common Floor or Magic Bricks or 99 Acres in India. On Redfin, I asked Sandhya to pick a house, any house, at the Queens PIN code.
Okay, let me just pick this first one.
It's a 5-bedroom house with just 2 bathrooms for some reason, and you can buy it for $700,000 only. If you scroll down, it has the usual property details.
Property details, schools around this home.
So details about the neighborhood, details about the house, like number of rooms, size of the house, parking, garage, utilities. And when you reach the bottom, the absolute bottom,
Public tax.
you get to a section called climate risk.
Climate risk. Yeah.
According to this climate risk section, the location of the house that Sandhya has picked currently sees around 8 big storms per year on average. In the next 30 years, it could see 21 storms each year with more rain per storm. So, nearly 3 times as many storms and more water, probably more flooding and more headache. Basically, what Redfin has done is that it's partnered with Climate Check, the website that we first explored, and it gives people a climate-related analysis for each of the listed properties, which, on the surface, looks useful because you can theoretically compare properties and locations and see what they'll each be exposed to in the future. Maybe you don't mind storms, but you just can't tolerate heat. Or maybe you don't want to face wildfires. You can choose accordingly. So would such information, would that be helpful for you?
I think it's helpful to get an overall picture. I think going forward, especially homeowners, I think at this point are educated enough and aware enough to where I think they would start becoming interested in looking into climate risks.
For a long time, climate data has stayed locked inside long jargon-filled papers and reports. But perhaps it's time to have climate information available to us, common folks, that we can actually put to use, like when planning where to rent or buy property. I won't get into the accuracy of climate check, but let's imagine something similar for India, for our cities and our neighbourhoods, bharatclimate.com style. Imagine being able to compare individual locations and properties and see which one will not get flooded or which one won't have water shortage and what the average temperatures these areas will see. What would it take to have this sort of hyper-local information for Indian cities? Answers after this quick break. Welcome back. Let's start with a basic question. How do scientists predict future climate?
That is one of our major jobs, and that's one of the things that we have done through the Intergovernment Panel on Climate Change. I am Roxy Mathew Koll, climate scientist at the Indian Institute of Tropical Meteorology.
Dr. Roxy has also been the lead author of some of those reports by IPCC, or the Intergovernmental Panel on Climate Change. Reports that come out from time to time telling us how our planet is and will be. Pardon my language. Well, this is how scientists like him predict the future.
So what we do is we use the science that we know, incorporate that into what we call models or what we call climate models. You can think of it as a set of equations or algorithms which represent the physical realm of ocean, atmosphere, biosphere, land, even the agriculture also.
Basically, these mathematical equations explain the physics, chemistry, or biology behind the different processes within our atmosphere, ocean, and land, processes that affect our climate. The equations describe, for example, what the Earth looks like, how big it is, how fast it rotates, how much energy from the sun falls on the planet, where all the land and water are, how much air there is, what all is there in the atmosphere, what's there in water, and what's there on land at different points. How does energy move between all of these, and how do they all talk to each other? The equations try to capture as many of these interactions as possible. Equations that are then translated into computer language. So what you have in the end are simulations of the Earth and its climate. To me, a climate model sounds like a video game, where you can practice racing a car without actually having to race a car. You can go too fast around the corner and see whether you crash or not. You can pick different kinds of cars and see how each behaves. So you create different scenarios, practice, and you learn how to become a faster racer. Similarly, we have only one planet. So climate models allow scientists to experiment with different scenarios. Say you want to know what happens if we continue to drive cars and burn coal and release greenhouse gases just the way we've been doing over the last 50 years. Scientists can set this scene in their models and then see what might happen to temperature, rainfall, sea level rise, and so on over the next 30, 50, or 100 years.
You are fucked. You are fucked. You are fucked.
What we get are climate forecasts. Dr. Roxy, however, wasn't a big fan of the video game analogy when I mentioned it to him. Would it be right to say that the climate models are like video games?
Well, in the video game, even if you lose, you can always go back and correct it, and it's exciting. But here, most of the scenarios we see for the future are kind of worst-case scenarios, which are decided by politicians. We do not, even climate scientists or common man, do not have much role in terms of decisions. So that's a huge difference. I'm not excited by by the results of this game.
He's right. The climate game, unfortunately, does not have any exciting results. Whether we cut down on our emissions moving forward or whether we continue to live the way we are currently, we've already set into motion certain effects of climate change. While we can slow down the damage, there's no turning the dial back because our planet is already heating up. But at least we can know what's coming in the future and make better choices, like where to live. So the question is, if scientists have a way to simulate the future, how local or fine can their predictions get? Remember, climate models have a ton of equations and variables to solve for, and these are represented as lines and lines and lines of code.
All these algorithms means it's huge amount of data being exchanged at every grid point of the Earth system. That needs a lot of computational power. And we have high performance computing systems or supercomputers. In fact, one of the fastest supercomputer in India is in our institution.
Even with supercomputers, analyzing all the data, solving all the equations, and predicting climate for every single point on Earth will take a huge amount of time and energy. So, researchers divide the Earth into grids that are about 100 kilometers or so wide. And then they run simulations for each of those grid blocks. These are global climate forecasts, and while they're very useful, they come with some limitations. First, their predictions are quite coarse. 100-kilometer wide grids cover huge areas and provide a zoomed out view. That's not very useful if you want to zoom in and know how climate change will affect a particular house or apartment in one particular neighbourhood. Secondly, these global models don't capture India's local processes that affect India's climate well enough. Like the monsoon, which all 1.3 billion of us depend on.
The monsoon is the key factor, because many global climate models do not represent the monsoon conditions well. So if you develop a model and doesn't showcase or highlight the changes of monsoon in the future, there is no use for us. So a futuristic climate model should definitely be able to bring out the changes in monsoon in the future as well.
Dr. Roxy and his colleagues are already working on India-specific climate models that capture the physics behind processes like the monsoon. But even these models make predictions over large areas, 50 to 100 kilometers or so. Can you zoom in further then? Well, theoretically you can, and weather prediction models have shown that.
So weather forecasting is for the next few days. You run the model and say how the weather will develop or a cyclone is coming up or anything like that. And we have extended range prediction. Beyond these 3-4 days, that's for like 2 weeks, how the weather is going to develop. And then we have the seasonal forecasting, particularly for the monsoon season, how the entire monsoon season will develop. So these forecasts are generally carried out at about 25 by 25 kilometer resolution or lower than that.
So why can't weather forecasting models make more of these localized predictions, even though you may not always agree with them? Well, firstly, the more you want to zoom in, the more number of grids you will have to divide India into. Say you want to know what will happen every 5 kilometers. Then, instead of dividing India into 100-kilometer grids, you'll have to make 5-kilometer grids. So you'll have many more grids to run simulations for. Now, weather models usually consider a few systems at a time, Dr. Roxy says. So they don't incorporate all the interactions between the ocean, land, and atmosphere that many climate models do. This makes the weather models faster to run. Also, weather is what will happen in the next few days or months, which again makes their computation relatively faster than climate, where the computer models will have to run calculations for several decades. So, one way to get better at predicting climate effects over small areas is to improve our computational power.
And also our understanding of the physics. Because just by improving computational resources and resolution of the grid point, we cannot expect improvement of the forecast, because we also need to have the physics at that shorter scales. Yeah.
It's like taking a photograph of a tiny bird high up on a tree with your phone camera. You can't just zoom in expecting to see crisp details of the bird.
Why is it still blurry?
Making it bigger doesn't make it clearer.
It does on CSI Miami.
Similarly, to predict what might happen at, say, 1 or 5 kilometers, you can't just zoom into predictions made over 50 or 100 kilometers and generalize it. You need to figure out how processes work at those really fine scales. And that is a hard nut to crack.
Especially when you are talking about a city, the urban setup matters a lot for the local climate. That can change the temperature in the region. For example, if the ground is concreted and the number of trees are less, the way the moisture develops or the way the heat is trapped in that city is totally different from if it is a rural area with a lot of trees and open space and ponds and lakes and all.
This is the urban heat island effect, where all the concrete and asphalt and glass causes a city to have much higher temperatures than areas on the outskirts or villages. The temperature differences become especially big during heat waves, like the one we saw in Delhi in early 2022.
So there was a 10 to 20 degrees Celsius difference. And this is for nighttime temperatures, okay? Nighttime temperatures between Delhi urban area and outskirts of Delhi, up to 20 degrees Celsius. That is huge difference.
Or let's talk about rain and floods.
Now, if you come to extreme rainfall, like for example in Mumbai or Bangalore or Kolkata or anywhere like that, then we again have to consider how that water is channeled through these land areas, how this concrete and drainage and rivers and so on. Yeah. So all these factors are important if you talk about cities and forecasting the conditions over there.
And it seems like we don't really have like good maps of stormwater drains in many of our cities.
Yeah, we do not even have proper elevation maps, or even if it is there, that is not shared well enough. We need actually, that's one point. If you want to be futuristic about our forecasts and all at a finer scale for cities for tomorrow, we need a good interdepartmental cooperation, particularly sharing data, which do not happen, sharing data and information which do not happen in India. Yeah, that's a shame.
Even if you had all the data, scientists still have to figure out how they all interact.
Which is quite challenging in terms of how do we put that into mathematical equations, and also how do we even monitor and have the data of all those information and incorporate this into models at a very finer scale.
It's hard, but not impossible to do. Dr. Roxy says that several of his colleagues at various universities, including the IITs, have been trying to collect their own local data by setting up things like weather stations, so they can create models for their own cities and localities. But these localized models, he says, are still at a crude stage.
But we do see that this coming up in a large scale in the future.
At the moment, though, we don't have these local forecasting models. So we don't know how climate change will affect, say, Bandra versus Thane in Mumbai, or Indiranagar versus Yelahanka in Bangalore, or Goriahat versus New Alipur in Kolkata. But we do have some research that's showing what effects we could see at a slightly broader level, at the level of our districts. More on that after a quick break.
Hello, I'm Dr. Indu Murthy. I work at the Center for Study of Science, Technology and Policy, a research-based policy think tank in Bangalore. And I head the climate, environment and sustainability sector at C-STEP.
Dr. Indu's team came out with a report last year. It tells us how climate change could affect things like rainfall and temperature in districts in southern India over the next 30 years.
And what we see is that for the southern region, predominantly when it comes to rainfall, an increase in the magnitude or the quantum of rainfall in both the Kharif or the primary monsoon season, which is June, July, August, September, and also to some extent in the Rabi season also, which is to do with the October, November, December period, is projected to increase in a majority of the districts of southern India. Now, that means we are looking at a wetter future.
I live in Bangalore and I'm already seeing it. 2022 was Bangalore's wettest year on record. And this constant rain and humidity, that affects the homes that we've paid good money to either rent or buy. For example, last year in our Housing Society WhatsApp group, there was this flood of messages about seepage, walls that weren't drying, and pictures of mushrooms that were growing out of bedroom walls.
I was about to say the same thing. I've had the same experience myself. See, I've lived in a very high rainfall town also, Sirsi in the Western Ghats, where I had experience of this. I lived there for 3 years. Heavy, extremely heavy rainfall because it's the Western Ghats region. Incessant rain for 3 months in a year. So I had this problem of mold. But now, in Bangalore this year, all my wooden furniture, I see mold formation. So, which I hadn't seen in the past. So, yes, you're right. It's kind of, and of course, seepage, especially in these old buildings and structures, that's become a very common problem.
So, if you pick a location that receives heavy rainfall, you will need to be ready to do something about mold and mushrooms growing on your walls and furniture. But in our districts, there are some other interesting rainfall trends as well.
Some of the districts which historically have no records of rainfall of greater than 100 are projected to have such incidences.
And so, if you move to a district thinking, this region remains relatively dry and I hate rains, so I'll pick this area to build a home, then you might be mistaken. Because when rains start getting heavier year after year, you will realize that neither did you build a home suited to handle this downpour, nor was the area equipped to handle all that water. Now, India's southern districts will not just get wetter, but also hotter.
Warming, it's unequivocal and it's across all the districts of southern India. Anywhere between 0.5 to 2 degrees centigrade, the warming in that winter minimum temperature might be a little more higher than what could happen in the summer maximum temperatures.
So, hotter summers and warmer winters, which we are already beginning to feel.
Yeah, it's kind of interesting. I mean, woolens are something that people would at least pull out some part of the year in Bangalore. But then in the past few years, you don't really need to keep yourself warm. There are very few days when you actually feel that it's colder. But otherwise, yes, definitely, the winter minimum temperatures are nowhere the same as to what it was in the past.
Dr. Indu's study gives us a glimpse of the future for some of India's districts. But predicting climate effects for cities is also going to be very important, especially as more and more people pack themselves inside already overflowing spaces.
Take the case of Mumbai. Now, currently, 2020, Mumbai population is around 20 million.
That's Dr. Roxy again.
By 2050, it is projected to double to 40 million. Yeah, that is one Mumbai on top of another Mumbai. And the climate challenge also by 2050, we might reach temperatures between 1.5 and 2 degrees Celsius. So all the extreme weather events that we see or saw until now in terms of heat waves, floods, droughts, cyclones are in response to that 1 degree Celsius change. Now, even as a climate scientist, I cannot imagine the tomorrow when it doubles to a 2 degrees Celsius. Obviously, all this will intensify, but it's not a linear intensification by several fold, and the area exposed also will increase, and population exposed, vulnerable population exposed will also increase.
How do all these people who move into Mumbai go about picking where to live? Of course, budget will trump it all, whether it's now or 30 years later. But let's put money and logistics aside. Then, perhaps, an app or platform like Bharat Climate could become useful.
What really needs to be done is to be able to use this data to make it open source and then actually present it to people in a form that will be easy for them to access.
This is Dr. Siddharth Singh.
I'm the author of The Great Smog of India, which is a book on India's air pollution crisis. And I'm also a researcher of energy transitions and climate action.
One thing I wonder about is whether property developers or governments would want information on local climate effects to be publicly available and easy to understand. I mean, which developer would want potential buyers to know that the area they are building on will face severe water shortage in the next 10 years? Or that the high-end villas worth crores of rupees will all see floodwaters every year.
It would also be important, perhaps, for there to be regulation in India which encourages this information to be easily accessible at the time of purchase or even renting. So, the various platforms that exist and the various realty developers that exist could be mandated to provide this information.
Regulation that perhaps makes it compulsory for climate risks to be made publicly available and for free, both on some public platform and also on property listing sites like NoBroker or Magic Bricks or Housing.com, where you can see risks for things like flood, heat waves, cyclones, or water shortage for each property that you're interested in.
But in the absence of all this information, you're really left to fend for yourself.
So, how would you fend for yourself if you were scouting locations for a home and you were worried about climate change? You could search frantically on Google, hoping you find some map somewhere showing you some risk, or some article that goes 6 climate safe locations in Mumbai or Chennai.
Number 7 will steal your kidneys.
Or you could do the old-fashioned thing where you talk to people.
Honestly, go out of your house and start talking to people and trying to understand the various kind of impacts that people have already seen. For example, have recent years seen unexpectedly high rainfall or temperatures? Because that could be a guidance of what the future holds. If we just, as a principle, understand that things will become more frequent and more intense over time. Secondly, to understand that if you're purchasing a home or a plot of land, does it lie in a low-lying area? Does it lie in an area which could perhaps have flooding at a future date? Also to understand by talking to people if the closest drains or nalas or rivers, have they been blocked due to unplanned construction or waste? So these are the kind of things that you will really need to look out for in the absence of credible information of what could be the likely impacts over the next few decades.
But let's say scientists come up with models that can predict climate risks for specific locations in your city. The question then is, who puts this knowledge to use? Will we see a gentrification where rich folks move into areas predicted to be climate safe?
So we would see more and more in the future that the rich are occupying high altitude areas and the poor and the vulnerable are occupying low-lying areas which are exposed to climate change. So that rich-poor divide will be exposed severely in the future, near future. Maybe it's already we do not have that habit of counting.
I think intuitively it's already happening where richer people are seeking out higher elevation areas in cities and they're looking where it's not flooded previously. So they're occupying those areas.
Exactly. I think so. This is important to consider for the future because real estate prices are already rising for high altitude areas. This has been shown for entire South Asia and East Asia, particularly coastal regions.
Although when you look at property prices in places by the sea, like in Mumbai, Chennai, or Goa, it doesn't seem like people really worry about climate change. But that should change in the future.
Just to give you a small example of where I live in Goa, there's a hill that ends at the sea. And there's a road that divides our part of the neighborhood with another neighborhood. And our part of the neighborhood is actually on the foothill.
Whereas the other neighborhood, he says, is right next to an inlet to the sea.
It's a very visual thing. But if there were to be a storm surge or if there were to be any form of flooding, all houses on the other side of the road will definitely be flooded. Whereas the houses on our side of the road probably won't be because it's a good 10 to 15 feet high.
So out of curiosity, are the houses on the other side of the road closer to the inlet, are they more pricey, more expensive?
That's actually a very good question. So in this specific neighborhood, they are not, but everywhere else around this inlet, they are. So where we stay, it's a little underdeveloped, it's a village, but just a few kilometers on the other sides, indeed, these houses are more pricier because they have a better view. You can actually see the sea, you can see the sunset. In fact, this reminds me of this point that was made by a climate skeptic or climate denying American senator or politician, where he said something like, what's the problem if the sea level is rising? If you own a home at the coast and the sea level is going to rise in the future, you can always sell that home and move somewhere else. The question is, who's going to buy that home? Who is going to give you money for that if it's going to be flooded out? but that's the level of understanding that people have as far as climate impacts go.
I won't lie. If I had to protect my future and I had something like Bharat Climate available to me, I would use it. But being able to choose a safe place to live in is definitely a privilege. And if science and experience tell us one thing, it's that our pool of safe places to choose from is quickly becoming smaller and smaller.
If you ask me if there is a safe place in terms of climate change, particularly in terms of climate change in the future, there is no safe place in India. So your imagined tomorrow is already happening now.
Which is why we can't just depend on being able to choose. We'll also have to make our existing neighborhoods and homes climate-proof. How do we do that? Well, part 2 of this mini-series will answer that, where you'll also hear from some of our guests again. But I'll leave you with a sneak peek.
I found this funny. Initially I did not believe. I thought this was nonsense. It was something like science fiction, raising a building. So I went to have a look at this.
Imagined Tomorrow is created and hosted by me, Shreya Dasgupta. Theme music, sound design and editing by Abhijit Shailanath. Abhishek Madan and Abhijit were the voices of the fictional ad. By the way, if anyone wants to build bharatclimate.com, contact me. Parvati Nair, Porni Ray and Mihira Ram helped with the research process. If you have any comments or questions, please reach out to us at imaginedtomorrow@gmail.com or via Twitter. That's it for today. Part 2 of this mini-series will be out next week. See you then.